Hi and welcome back to the course on cloud computing. The topic we are going to cover today is platform as a service, and we are understanding the basic concepts of cloud computing. So when we talk about platform as a service, we can see that it's a platform as a service solution provides a collection of hardware and software resources that developers can use to build and deploy their applications in the cloud. Further, depending on their needs, developers may use Windows-based platform or they can use a Linux-based platform in order to deploy their applications. So when we talk about a platform as a service, there are lots of platforms available in the cloud. You can get Microsoft Azure Cloud, you can get Amazon Web Services, and we have Google platform as a service as well. Now, Google's PaaS, which is platform as a service, like all platform as a service solutions, Google App Engine provides the administrators the underlying system software, allowing the developers to focus on their own applications. So they are providing you a platform through which you can develop your own applications. There are lots of set tools available and toolkits with the help of which you can easily develop your applications and deploy it on their cloud. Currently, Google App Engine provides support for a variety of programming languages. For example, if you want to develop applications on Java, for Python, Node.js, and Go, all those platforms are supported. You can easily use their toolkits which are available on their platform to develop their applications, test them, and deploy them on the cloud. To help developers get started, Google allowed them to get started with Google App Engine for free. It means you don't have to pay anything. You can simply sign up and try to build your own free web application using their tools. As the application grows in use, measured by the network traffic into and out of the application. So if people would start using the application and it is used, the monthly price would increase for that, because then they'll say that you are actually using that application and it is adding any benefit to you or your organization. Now, the primary goal of Google App Engine features include the following. For example, it supports for the dynamic web pages. You can support an application which can add value or add as an add-on to your current website. Data storage and query support. A fully managed database is available on their website through which you can run different queries, get the data in and out of the application, load balancing for the application scalability. So if there is more load coming to your application, it would scale according to that. Then it even supports APIs, which is application programming interface, for the applications based email through Google services and lots of other things. So if you have certain things and the information which is available on your application and you want to call it through different APIs, that feature is available as well. It supports the application versioning, so you can maintain the version of the application that you are using for support and upgrades, and built-in application diagnostics. If any application is performing low due to any reasons or it requires certain tweaks, you can search it in the diagnostics. And then the application security is a built-in platform where the application which would be built using their tools, it would be secure enough for any kind of web-based attacks. Now, as you can see that a developer is developing an application using his computer. He can upload it to the local Google App Engine environment. It would go to PaaS environment of the Google data centers, and it would be accessible from there globally. Now here they are showing what Google is offering you. You can build highly scalable applications on fully managed serverless platform, and they are even showing that which languages you can use on their platform. New customers can get up to $300 of free credit to spend on Google Cloud using the first 90 days. So you can consume this free credit to check your applications. Now, internet service providers, web access in 1990s, that's where it emerged when users used to connect to the internet using the dial-up modems. The internet connection wasn't very stable and powerful in most of the parts of the world. So hosting your own server on premises was a big issue. You were not able to host your own server because it required a constant connection to the internet and enough bandwidth so that the external users would be able to connect to the website. For smaller companies, however, the cost to connect to the internet was prohibitive. As a result, internet service providers which maintained the web servers and high speed, high bandwidth connections came and it emerged with the passage of time. Now, developers used to develop applications in HTML, Perl, active server pages, which we called ASP at that time, to develop the content locally and then use file transfer protocol in order to host those pages to the remote web servers through which were restricted within the internet service providers. So internet service providers were providing you internet. They had their own servers on which you were able to host your own applications. Now, we are still using FTP protocol if we want to host any of the pages, or if you want to transfer the files for the applications that you have developed to transfer it to the remote servers. We are still using FTP for that. But the biggest problem at that time was the internet connection, and it was quite expensive to maintain your own servers at your premises. Now, the advantages of internet service providers was that it was a reduced cost. The internet service provider had the high speed and high bandwidth internet connection, which it shared across several companies. So if a website is hosted with the internet service provider, it had the internet access and the website was globally accessible to the users. Now, less server administration, the ISP manages the servers to which the developers upload their solutions. So they were taking care of the servers. The developers, all they need to do is develop application and simply host it on their servers. Now, less hardware to purchase and maintain, so it wasn't a big headache for the companies to maintain their own server. The ISP used to purchase and manage the hardware and manage the infrastructure, such as the operating system and rest of the things, including the licensing and any other applications which were installed on those servers at the remote location. Now, the greater system uptime through the use of the redundant hardware resources, the ISP provided high system uptime, so there was no problem about the power, backup, cooling, and other things. They were taking care of it. They were taking care of everything on their premises. Now, potentially scalability, the ISP can move to high demand applications to the faster bandwidth connections, and you had to pay extra for that if you want to have a premium package and a service which is dedicated for your own application. Now, then came these blade servers. Blade servers were quite successful at that time because it allowed the companies to reduce the server footprint, power requirements, and the heat within the data centers. They consumed very less space, and we were able to run heavy applications on it using those blade servers. Then we can see the evolution of platform as a service. Mainframe computers came in 1960s to 85. Then in 1985 we had the individual PCs which people purchased and placed them in their houses for basic applications. Microsoft Word and other applications were there at that time as well. Then we had an era of local area network in 1990s where we had storage which was bigger than 1980s, and we had a network where we could share the things on the network, store the things on the network. In 1995 we had the ISPs. They had their own central storage and servers through which we hosted the applications over there. And in 2008 is the time when the platform as a service or the cloud concept came into practice, where people started using the cloud services in order to host their applications in the cloud. Then we have different advantages of platform as a service. It's a lower total cost of ownership, means that the companies no longer need to purchase and maintain expensive hardware for the servers, power, and data storage. Now consider, if you are maintaining a data center yourself, you'll have to take care of everything which is related to the servers, servers, upgrading, and then after 4 or 5 years, when the speed of the servers which is available in the market would be quite higher, or when you'll end the support contract and all those things, you'll have to upgrade the hardware, or maybe if the warranty of the servers was 2-3 years or 5 years, after that you'll have to change the servers to make sure that your services are up and running. You had to spend a lot of money on that, whereas in the platform and as a service or in the cloud ownership, you don't have to worry about all those things. That's the responsibility of the cloud service provider to make sure that the hardware is up and running, it's up to the mark, it is able to provide all the services to the customers who are accessing it. You don't need to worry about the power and data storage. The power, the backup power source, and all those things are maintained by the cloud service providers. Even the data storage and its backup is a complete responsibility of the cloud service provider. Now, lower administration cost overhead, companies shifted the burden of the computer system software administration from in-house administration to the employees of the cloud provider. So now they have dedicated experts or the cloud service administrators who are taking care of the data centers, which are hosting lots of different websites on their servers. Now, if you are maintaining it yourself in your organization, you'll have to have a security team, you'll have to have a network team, you'll have to have the server administration, data center operations, and all those different teams who are taking care of the servers, which are good for one organization only. Whereas in the cloud service provider, the complete ownership goes to the cloud provider. How they are maintaining it, it's completely up to them. You'll be paying a certain amount to avail those services for your organization. More current systems and software, the cloud administrator is responsible for maintaining the software versions and the patches of the installations, etc. So if you have a server on premises, you'll have to maintain all the updates, backups, patching the servers for all the known vulnerabilities, updates, upgrading the service packs, and all those things. Now that's a complete responsibility of the cloud service provider. Now you don't have to worry about all the updates of the server, which operating system is being used, and whether you must upgrade the operating system or not, what are the licensing fee cost, and all those things. It's all responsibility of the cloud service provider. Now it increases the business and IT alignment. Company IT personnel can focus on the solutions as opposed to the server related issues. So now they can focus on the operations side rather than working on the administration of the servers itself, making sure that they are up and running, the cooling is enough, the backups are perfectly fine, they are not having any issues on that. So it's a completely now responsibility of the cloud service provider to maintain all those things. Now, scalable solutions mean that the cloud-based solutions can scale up or down automatically based on the application resources demand. Companies pay only for the resources that they consume. As we gave an example of the student registration period, that during the registration period, if you are maintaining servers on premises, you cannot expand the capacity or the overall resources which are available on those servers. It's locked to a certain level. For example, it can cater around about 500 users simultaneously. If you need to cater all 2000 students during the registration period, you'll have to upgrade the servers. You can upgrade the servers, but the problem in that is that you need that computational power during the registration period only. After that, throughout the year, you won't be consuming the servers up to that capacity. So in relation to that, if we are going to a cloud service provider, you can have a low-end servers, but you can define it that during the registration period, when you need more resources, you'll get more resources, which we call it as the resources on demand, and then you'll pay for that time when you'll be consuming those resources, and then it would come back to its original position. Now that's a console through which you manage your website or applications. If you need to install anything on a cloud, you have a graphical user interface. You can back up the server, you can look at the files, you can check different images, the directory and its permissions, the storage, how much you are utilizing it, different accounts who are accessing the FTP, or to update the files on the servers, or the disk space available. You can maintain the backups. You can define the backup scheme yourself. If you want to take the backup now, you can do it. Otherwise, it would schedule itself to maintain the backups at a certain time. You can install different applications and can take care of your domain and subdomain and DNS zone transfer, etc., using the web-based console. So you don't have to worry about managing the server physically. All you need to do is you must be familiar with this cPanel through which you maintain your own installations on remote server. Now, there are certain disadvantages of platform as a services, concerns about the data security. Some companies are hesitant to move their data storage to offsite, because since they have some sensitive information, or they don't want their data to be compromised, or still they have certain concerns about the data which is shared on one server and other tenants are also using the same server. So some companies still resist moving to the cloud. Nowadays, after encryption and all those things, this is very safe to have a cloud-based solution. There are set protocols. You can even define your own encryption algorithms which could be used on a cloud-based service. Now, the challenges to integrating cloud solution with legacy software. A company may need to support on-site solutions as well as cloud-based solutions. Communication between the two application types may be difficult or impossible. So if you were using any application which could be a legacy application which you developed in a language which is not supported by your cloud service provider, it would be a hurdle to shift your application to that cloud service provider, unless and until if you'll migrate the application or you'll rewrite the application so that it works or it's compatible with the cloud service provider. The risk of breach by the platform as a service provider: if the company providing the PaaS service fails to meet agreed upon service levels, performance, security, and availability may be at risk, and moving the application may be difficult. So these are the still valid concerns for most of the people who are still reluctant moving to the cloud when it comes to the performance, security, and availability of the applications. But if we'll see the hierarchy or the structure of Amazon Web Services, when we are choosing an instance to be available in the cloud, it asks you the primary instance and the secondary instance. For example, if you want to have one instance in North America, the second instance cannot be there in North America as well. You'll have to choose a different geographical location where a replication of your server would be maintained, or the replication of the data would be maintained. So in that way, if a complete network is down at one part of the world, your services would be running from the other part of the world, which is maintaining a complete backup of your application, your database, and other things which are hosted in the cloud. So that was about platform as a service. Thank you very much.